Hello there, I'm Jamie. Welcome to another session of Vista Export Services. In this class, I'll be taking you through the process of building parts of the scene, shading, texturing, lighting, and rendering the final scene. As you can see, the specific scene is quite bare, and all textures have been stripped off, so we're literally starting from the ground up here. So without further ado, we're going to start with the floor material. Before we do so, we're going to the Customize toolbar and choose the unit setup option from the list. Users often switch between the display units depending on the values they need to type in. If the values are too small, I usually work in millimeters. If the values are too big, I work in meters. In other cases, depending on the country you live in, some people might use the US standard, custom, or the generic units display unit. Otherwise, it'll be just a metric system as a standard. It's worth mentioning that these units are only for display purposes and do not affect the physical scale of the scene. However, the system unit setup does affect the physical scale of the overall scene. For instance, if the scene objects look too small, you'd need to increase the system unit scale values. In this case, it'd probably be 1 unit is equal to 1.5 or 2.0. Every time you change sensitive values such as this, you need to measure the scene to check if the scale of the overall scene is correct. Equally, when you receive a scene from a third party, always check the unit setup values and measure common objects in the scene, such as floor to ceiling heights, chairs, etc. For the time being, we're going to set up the display unit scale to meters. The next step is to load up the vray rendering engine. To do that, let's start by opening the Render Setup dialog by clicking on this button there. In a Commons tab, load up the vray Advanced 3.6 from the list. An earlier version would also be okay. Most of the rendering settings will be quite draft because we'll start with the test renders first. Open the vray tab. Under the image sampler parameters, change the type to bucket. If the bucket type is not available in your version of vray, choose the progressive type. Often choose the bucket rendering type because it's easy to track the rendering progress and the bucket errors in a vray buffer. You can also use the mouse to track the renders. Some of the key vray settings are actually hidden under the default button. To make them visible, simply double click on each of the default buttons to expand the parameters. As you can see, after double clicking on a default button, it will turn into an expert type with all the hidden parameters in display. Under the image filter, choose the area type. However, feel free to use any of the other filters listed. Under the bucket image sampler, to start as draft, we can set up the minimum subdivisions to 1 and the maximum to 4. The lower the maximum subdivisions, the quicker the rendering times will be. In the noise threshold, the lower the values, the less noisy the renders will be. Also, the rendering times will increase substantially. For draft test renders, we're going to leave the values as they currently are. Under the color mapping rollout, the default type is raw and hard. However, for the purpose of this exercise, we're going to change it to exponential type. This color mapping type helps to correct the overexposed areas and makes most renders look more realistic in general. As previously done, double-click on the default button until the expert mode appears. As you can see, other functions such as subpixel mapping, affect background, and the linear workflow are now visible. Also, enable the subpixel mapping option. Enabling this function often helps to correct renders with small white dots. Open the GI tab and turn the primary engine to irradiance map and the secondary engine to light cache. Also, enable the expert mode and turn on the ambient occlusion function. Ambient occlusion is crucial for adding depth and shadow details to a scene. Otherwise, your scenes will look a bit flat. Open the irradiance map and set the preset to very low. Again, we'll be starting from the draft renders for quick tests and gradually increase the settings as we progress towards the final renders. Also, enable the Show Direct Light option. This function allows the direct light to be seen during the pre-calculation process. So if you're not happy with where the lights are being cast, you can always cancel the pre-calculation. Open the light cache rollout parameters. Set the light cache subdivision to about 600 for a quick and fast render. Next, we're going to start with a normal camera and later use the vray exposure control through the environment. Under the standard cameras, let's click on the target button to create a target camera by clicking and dragging it on the top viewport, like so. Because we'll be moving the camera, we're going to open the modify panel while the camera is still selected and change the camera type to free. A camera without a target will give you the flexibility to move around more freely. You can always add a target if and when necessary. The first thing that we're going to do is to set the camera height just by moving it up slightly. More often than not, the cameras are set at eye level, which is 1.64, 1.65. There are times when you may need to go a little bit lower than usual or a bit higher than usual. To get the right frame, let's rotate and move it slightly. To make sure the camera is at the right height, we're going to use the tape tool to measure it. To do so, open the Create panel and click on the Help Us button. Next, click on the tape tool and drag to create it on the front viewport. Next, we're going to open the Modify panel and set the length value to about 1.64 meters, which is the standard eye level. Back in the viewport, we're going to ensure the base of the tape tool is on the base of the sofa, because that's where the floorboards will go up to. The next step is to move the camera up to the top of the tape tool, widen the camera lens to 20 mm to see more of the penthouse, and rotate the camera to frame the shot a bit better. Because the camera lens and the render output size work in conjunction, we're going to change the frame size to landscape. Open the Render Setup dialog and the Command tab. In the output size group, change the width to about 4,500 pixels and the height to 2,600 pixels. As you can see, the overall shot is already looking much better. To make the framing more appealing, let's rotate and tweak the camera a bit more. To correct the verticals, let's add the camera correction modifier by right-clicking on the selected camera and choosing the camera correction. Next, we're going to turn back this camera into a target type and move it so we see less of the ceiling. After a few tweaks, the final camera should look similar to this view. Alternatively, simply merge the final camera from the max file under the name of Camera 2. The first surface that we're going to create are the floorboards. For this, we're going to use a plugin called Floor Generator. You don't need to install anything. Select and isolate the floor first. This plugin is free to create simple floorboards. However, to generate more complex floorboards, you need to purchase it for €20. Floor Generator works best with splines and shapes as opposed to surfaces. For this reason, we're going to delete the extrude modifier first. To download this plugin, simply Google Floor Generator. As you can see, it belongs to a website called CG Source. There, you can find the free version and the full version. Also, you have the multi-texture procedural material to help you randomize the textures on the floor. After downloading and unzipping the plugin, simply copy and paste the DLT file from multi-texture and the DLM file from the Floor Generator in the plugins folder of the version of 3ds Max you're working with. To load the Floor Generator, we're simply going to open the Modify panel and find it from the list. As you can see, the floorboards and the extrusion have been automatically generated. The first thing that we're going to do is to change the direction of the floorboards. To do so, under the general rollout parameters, begin changing the direction values to about 35.85 degrees. For this project, the client had given us the real dimension of the floorboards. Because we'll be working with small values, let's change the display units to millimeters. As mentioned earlier, these values are only for display purposes. Let's set the max length value to about 1860 millimeters, the max width to about 148 mm, the grout to 3 mm, and the offset value to about 32.187 mm. Deselect the isolation mode and set the extrusion to about 31.671 mm. We can also enable the move tool and move it up slightly to the base of the sofa. Next, we'll start working on the floorboard material. Isolate the floorboard, open the material editor by clicking M on your keyboard and select new material slot, followed by renaming it as floor. The following step is to load up the multi-texture procedural map. To do so, click on the standard toggle first. In the material browser dialog, expand the vray material rollout and choose the vray material shader from the list. Once loaded, click on its diffuse toggle and load up the multi-texture procedural map under the standards list. Inside the multi-texture parameters, click on the Manage Texture toggle, followed by clicking on the Add Bitmap toggle. In the dialog, you have a range of multi-map textures downloaded from the CG Sources website. There, you have all the sets of woodboard based on real dimensions from manufacturers. You can simply pick and choose the ones your client might require. After downloading one set, you should end up with a number of variations as seen here. Select the entire set and load them into the Manage Textures dialog. After they're all loaded, simply close the dialog. Assign this material slot to the selected floor and enable the button to show the shaded material in the viewport. There's no need to apply the UVW map modifier. It does it all automatically. The next step is to start randomizing the gamma appearance by setting up the values to about 0.05. It's not prudent to go higher than this value, as the difference between floorboards will be too apparent and might look a bit unrealistic. Also, set the distribution to about 61.0. The next step is to bring up the entire surface to life by adding sheen and bump to it. To have the full control over the reflect settings, deselect the Fresnel reflections. By default, the highlight glossiness value is locked to the reflection color swatch. To control both values separately, simply unlock the highlight glossiness value by clicking on its button. The following step is to change the reflect color swatch to a brighter tone and start tweaking with the highlight glossiness and reflection glossiness values. When tweaking the reflection and glossiness values, it's best to double click on the material slot to maximize the preview and float the dialog as seen on the right hand side of the screen. To add a bit of sheen to the surface, reduce the highlight glossiness value from 1 to about 0.63. Note how the size of the highlight glossiness grows and spreads around the surface as you reduce the values. Click and hold the color swatch to bring up the color selector dialog. As you move the slider values to a brighter tone, you can clearly start seeing the reflection amount being displayed as checkers in a floating material preview. As you can see from the checkers material preview, the current reflectivity looks too linear. To disperse or diffuse the reflection slightly, simply reduce the reflection glossiness values. In the real world, most surfaces reflect light unevenly. To replicate this effect in 3ds Max, we're going to first select and drag the contents from the diffuse toggle into the reflect toggle. Choose the option to copy and OK to close the dialog. A copy of the multi-texture procedural map is now inside the reflect toggle. Reflection and glossiness work best with black and white and grayscale materials. For this reason, we're going to use the color correction procedural map to achieve this. To do so, click on the reflection toggle first. Inside the reflect map parameters, click on the multi-texture toggle. In the material map browser dialog, choose the color correction procedural map from the list. In this replace map dialog, choose to keep old map as submap and OK to close it. First, we're going to grayscale all the multi-texture bitmaps by dragging the saturation slider to about -100. It's worth noting we are inside the reflect map toggle, so all these changes will only affect the reflections. Under the lightness parameters, begin dragging the brightness slider to see how it's affecting the surface. The further to the right you go, the more reflectivity you'll get, and vice versa. The contrast values will also help fine-tune the results. After a few tweaks, the contrast value was set to about 100 and the brightness value to about -45,515. Let's go back to the main vray parameters by clicking on the Go to Parent button. The next step is to copy the contents from Reflect toggle into the Highlight Glossiness toggle. Just drag and drop it there. Choose the option to copy. Go inside the Highlight Glossiness toggle. Set the brightness value to about 85.382 and the contrast value to about 22.259. As previously done, we are going back to the basic parameters and copy the toggle contents from the Highlight Glossiness into the Reflect Glossiness toggle. Inside the color correction, let's set the brightness to about 12.957 and the contrast to about -100. The following step is to go back to the basic parameters and begin mixing between the external values and the color correction parameters. Scroll down and expand the Maps Ruler parameters. Currently, vray is using 100% of the contents inside the Reflect toggle. To mix the content inside the toggle with the Reflect color swatch, simply decrease the Reflect value to about 70. So now, vray is using 70% of the toggle content and 30% of the Reflect color swatch. Next, we're going to reduce the Highlight Glossiness value to 40. By reducing the Highlight Glossiness value to 40, vray is now using 40% of the toggle content and 60% of the Highlight Glossiness values from the basic parameters. To add bump to the surface, simply right-click and choose to copy the grayscale content from the Reflect Glossiness toggle and paste it into the bump toggle. You can actually see the results in the material preview. Next, we're going to exit the isolation mode. Let's open the Render Setup dialog and change some of its rendering settings.